Systems by graphing. Solve with intercept form. To graph lines, we're going to remember the equation y equals mx plus b. We're going to start with the y-intercept, or b, and we're going to use the slope, or m, to find the next point. So let's look at some examples. Example 1. The temperature in town A is 9 degrees and falling 2 degrees every hour. In town B, far away, the temperature is 4 degrees and rising 3 degrees every hour. So temperature in town A can be represented as y equals negative 2x plus 9, or temperature in town B can be represented as y equals 3x plus 4. So the x is equal to the hour, y is the temperature. So we're going to solve the system of equations by graphing first to find the hour when the temperatures will be equal. So let's go ahead and graph this. We're going to have more positive and more x and more y. Let's go like that. So we have 1, 2, 3, 4, 5, 6. Then we're going to go and let's do increments of 2. 2, 4, 6, 8, 10. Now, let's go ahead and graph these two equations. Let's go ahead and graph town A first. So we have y equals negative 2x plus 9. So our b-intercept is our 9. So let's just go ahead and draw a point right there. Then we need to plot the next point. So we're going to look at this, right, like this negative 2x. So that means we're going to go down 2 over 1. Because we have a negative slope. So it needs to go right. It's going to go down from left to right. So we go down negative 2 over 1 because it's a negative slope. So then we go down negative 2 over 1 because rise over run. So we have negative 2 and then it's just over 1. Right. So there is our next point. So let's do it one more time. So we need to go down another 2. So we go to 5 and go all the way over to 2 this time. So we have a graph that looks something like that. Then let's draw our next line. So we have y equals 3x plus 4. So let's look at our b-intercept first. So we have a 4. Let's go ahead and draw a point of 4. Then we have our rise over run, which is 3 right over 1. So that means we need to go up 3 over 1. Then we need to go 3 over 1. So we need to go up 3. So remember, this is increments of 2. So this is 3, and we go over 1. And so we have a point right there. So we don't actually have to draw anymore because we could just draw the line, kind of continue on. But the thing that we really want to know is when does our temperatures are equal? So what hour is that? Well, we can see that the temperatures are equal when it's 7 degrees and after a whole hour. So the point then would be 1, 7. So this would be our solution, where we solved these two equations, not algebraically, but through graphing to find the points when they're equal, which is 1 and 7. So now let's do another example. Example 2. 2x minus y equals negative 4, and we have x plus y equals 1. Well, we can see from this equations that they're not set up into our y equals mx plus b. So we need to first solve for these equations into this form. So let's go ahead and look at the first one. So we have 2x minus y equals negative 4. Well, I would just go ahead and put plus y on both sides because we want y to be positive. So now we have 2x equals negative 4 plus y. Then next all we do is go add 4 on both sides. So now we have 2x plus 4 equals y. Because this is just 0, that's just 0. Or it could be written as, right, so we'll flip it. So here's our first equation. Then we can see all we need to do for the second one. So we have x plus y equals 1. Let's just go minus x on both sides. So we have y equals negative x plus 1. So this is our second equation. This is our first. So now let's just go ahead and graph them. So we first graph our b-intercept. So we have 4. So here's our origin. Let's go to 4, 4. Then it's actually 2x, so 2 over 1. So if we went up, so we went up 2 over 1, it'd be a point right there. Even though we don't have that point, but we can see them. Now we need to go, let's do another point. So let's go down 2 over 1. Right, because if we go negative 2 over negative 1, that's still a positive slope. So it gives us that positive slope, like this. And then the next point would be right there. Right, so we can just see how this works, like this. Now, we have drawn this one. And you can see, right, if we were to go here, we need to go up 2 over 1. Then we go up 2 over 1. Or when we go backwards, we go down negative 2 over negative 1, which is still a positive slope. Now let's do the other one. Let's get a different color. Y equals negative x plus 1. So let's go ahead and draw. Our b-intercept is right there because we have this 1. So that's our b. Now we have negative x. So that's negative x, which is 1 over 1. So we need to go, that means we're going to have a negative slope. So we're going to go down 1 over 1. So then it gives us that slope going downhill, right? And so we just draw. And then we can also go up 1, negative 1, right? Because that's just how we keep it. So what's really important is right here. So this is the point when they're both have the same point to make them both equal. So if we plug in, so let's go negative 1, up 2. So this is the point when both graphs are satisfied. So what does this negative 1 and 2 really mean? It just means that it satisfies both equations. It means that this point could be used for either equation to satisfy it, right? Because if we were to have negative 1 right here, plus 2, that equals 1. Because negative 1 plus 2 is 1, so 1 equals 1. Let's also put into our first equations. We have 2 times negative 1, so that's negative 2 minus 2 equals negative 4, which is satisfied because negative 2 minus 2 is negative 4. So these both are satisfied. So that's really what that means. When we solve for it by graphing, instead of solving it algebraically, we could have come up with that, but we solved it through graphing this one.